Okay, so what we have here is a hydrated sample of sodium sulfate. We're told that the mass of the hydrated sample is 5.99 grams and the mass of the anhydrous sample is 3.11 grams. And we're effectively asked, well, what's the value of x in this situation? Now, what does x actually tell us? Well, if we look at the equation we have here, in effect, what x is saying is for every 1 mole of Na₂SO₄, how many moles of H2O do we have? Right, that's more or less what x is saying. And x is actually going to be an integer value. It needs to be an integer value. So, okay, so how would I go about working that out? Well, we've got masses here presented, but we're really trying to compare amounts of substance. So the first thing I'm going to do is I'm going to try and figure out how to convert these mass values into values for amount of substance that make sense. Okay, so for sodium sulfate, this particular mass is sodium sulfate and H2O, right? So for I want to figure out the amount of substance, the number of moles for the sodium sulfate. So I'm going to be using the anhydrous sample mass, which is effectively the sample that does not have H2O in it, right? So so how am I going to do that? Well, I'm going to use the equation that relates moles, mass, and molar mass, which is the number of moles N is equal to the mass M divided by the molar mass MR, right? Now, in this particular case, the mass is 3.11, right? So this is specifically for the number of moles of Na₂SO₄, yes? Is equal to the mass, so this is going to be 3.11 divided by the molar mass, right? So, but we need to work out the molar mass of Na₂SO₄. So if I go here and I say, well, what's the MR of Na₂SO₄, right? Well, that's in effect going to be, well, if you look at the periodic table here, what are some of the relevant equations here? Well, sodium, of course, oxygen, and sulfur, right? And for convenience, I do have the elements here as well. So, so Na2, that's going to be sodium. So 23, relative atomic mass, 23 times 2. So 23 times 2, right? Plus, and then for sulfur is 32.1. So plus 32.1 plus what it is for oxygen times 4, so it's 16. So plus 16 times 4, right? And that's going to be 142.1, right? And that's going to be in units of grams per mole, right? Okay, so the other thing in this context is, well, okay, we used the value 142.1, work that out. Yeah, so let's focus on this first. So 142.1, and if you do have a go at working that out, what you should find is that you get 0.021 886, and that's going to be in moles, right? Okay, so I've given this to 5 significant figures. The other thing I'm going to do at this point is, although we have the moles for the Na₂SO₄, we do also need the moles of the H2O, but we haven't explicitly been given that in the question. But we can work out what the number of moles is. We can just do, well, in effect, if we get the hydrated mass minus the anhydrous mass, what we're effectively doing is we're saying, well, the mass which contains the water, and we've got the mass here which doesn't contain the water. Of course, the difference is the water, right? So if we just do the difference, we would be left with the mass of the H2O, right? So in this case, it's 5.99 minus 3.11, right? That's effectively going to give us our answer, which in this case is going to be 2.88, right? And that's going to be in grams, right? Now, great, we've got the mass value, so we can say the number of moles for H2O, right, is going to be equal to 2.88 divided by, and we need the molar mass of H2O. So let's go back to the periodic table. And so we've got hydrogen, oxygen here. So molar mass MR of H2O. You may already know what the value is for this, but I'm going to go through the process anyway. So 16, and then, you know, times, that would be times 1. So I'm just going to leave it as is, plus, and then H2, right? So that's going to be 1 times 2, okay? And what does that give you? That effectively gives you 18, okay? And the units of that, that's going to be in grams per mole, okay? All right. So it's going to be divided by 18. Now, if you do work that out, we should find is that you get 0.16, okay? And that is going to be in moles, right? Okay, now the other thing we need to do here is we do need to consider the fact that now we need to compare. We need to compare the moles we got for Na₂SO₄ and H2O. That's going to get us closer to really knowing, well, that question of for every 1 mole of Na₂SO₄, how many moles of H2O, right? So in this case, that's gonna, so for Na₂SO₄, we've got 0.0. So I'm gonna put the Na₂SO₄ on the left hand side, right, for clarity. I'm gonna just for it's easy to compare it this way, right? So number of moles of Na₂SO₄, then on the right hand side I'm gonna put the H2O, so number of moles of H2O, right? And what's that going to give me? Well, on the left hand side it's going to be 0.021886, and on the right hand side it's going to be 0.16, right? Okay, now if we want to really make that comparison, how are we going to make the ratio make sense? Because it's for every 1 Na₂SO₄, how many moles of H2O? Well, we want to get the left hand side molar value to be 1, and the way we can do this straightforwardly is simply dividing it by itself, right? So that's exactly what I'm going to do. So I'm going to divide this by 0.021886. And that's of course going to give me 1, right? Because it's divided by itself. Now, because it's a ratio, what I do on the left hand side, I also do need to do to the right hand side as well. So on this side, I do have to also divide by 0.021886. And when I do that, what am I going to get? Well, I'm going to get 7.3106, right? Now, in the particular context of what I'm looking at here, I am looking for integer values, basically. I want an integer value on the right hand side, so I'm going to round it to the closest integer value, the closest whole number, so which in this case is 7, right? So it has to be rounded down to 7. So what I can therefore say is 1 is in the ratio of what is approximately 7, right? And why am I doing this? I'm doing this because x needs to be an integer value, right? So, and we can say therefore x is equal to 7, right? And what does that mean? Well, therefore the formula would be Na₂SO₄ dot 7 H2O, right? And since we worked that out, we can also, you know, in the formula above here, we can put in that value. So it's going to be a 7, right? And yeah, so that's, in this context, that's how you'd work that out.